talk about dilation. So this says a dilation requires a blank point and a blank blank. So look at these figures here. What type of point do you think a dilation requires? A center point. A dilation requires a center point, so a point that we're focusing on, right? And then what other thing do you think you need to make something larger or smaller? A what? We were just talking about it. A scale factor. When have we used scale factors in previous chapters? In similar triangles or similar figures, correct? So this is going to look a lot like that, okay? All right, so this figure right here is showing you, this is your preimage, this is your image after a scale factor of 2 at center C. So what this means is that from C to A is a distance, correct? Then there's also a distance from C to A prime that has a scale factor of 2. So what do you think this right here is going to be? Triangle ABD is a dilation of triangle, A prime, B prime, D prime of ABD. So C times A is going to be what? 2 CAs. So the distance from here to here is going to be twice as big as the distance from here to here. Make sense? They are, which ones are congruent? Yes, but it won't always be that way. That just happens to be because it's twice the size. Sometimes it'll be 3 times. Sometimes it'll be smaller. Okay, so this one should be what? 2CB, 2CD. Now over here, our center is here that we're concentrating on. And our figure is actually, our preimage is MNOP up here. What's happening here? It's getting smaller. By what factor? It's 1/3 as large as this one. So the distance from here to here is going to be 3 times larger than the distance from here to here, right? It would be 1/3. So all of these would be 1/3. Moving on. It's just all of them are 1/3. 1/3 of the original image or pre-image. So these are the only 2 definition type of explanations that I wanted to give to you because they're a little bit, well, I figured if you went and looked in your book and tried to reference your book, I wanted you to at least be able to see this. Okay? This one's a little bit harder to understand. This one's pretty easy. Scale factor. So if the absolute value of R is greater than 1, the dilation is enlarged. Which makes sense. You multiply anything by anything bigger than 1, and it's going to be larger. Correct? If the absolute value of R is in between 0 and 1, it's a dilation or a reduction. So what numbers are in between 0 and 1? Fractions, right? We're making something smaller, we use a fraction. If R is 1, then the dilation is a congruence transformation. Anytime you multiply something by 1, you get the same thing, correct? Okay, so that takes care of that. Similarity transformation. Okay, so doesn't this look a lot like similar triangles that we were doing before? So similar triangles would say that if I have this larger triangle and I have this smaller triangle, then their bases, wouldn't their bases be similar? We'll call that one Y. Okay, well this statement right here is basically explaining that. So let's read through it. If a dilation with center C, so here's the center, and a scale factor R transforms A to E. So here's the, this is the preimage, A to B. If this distance right here is reduced to this distance here, and the same thing on this side, we can also say that this line is reduced by the same scale factor. Does that make sense? Sort of. I know it's pretty abstract. So in other words, we figured out that this distance and this distance, the difference, the scale factor of these distances, if I measured each one of these going from x to n, x to o, x to m, and x to p, they would all have a scale factor of 1/3, correct? Well, this is saying that if these have a scale factor, let's just pretend it's 1/3 again, okay? If this has a scale factor of 1/3 and this has a scale factor of 1/3, then AB compared to DE would also be 1/3. It would be the other way around. DE is the new image. It would also be 1/3. Now you see what I'm saying? In a way. I want to hold off right there for 1 second. It's difficult to explain it in terms of R, okay? But when I'm explaining it in terms of, let's go back and look at this one. If this is if all of these have a scale factor of 1/3, you guys understand that? All these distances have a scale factor of 1/3. I should have just done it this way. Then doesn't MN and M prime N also have a scale factor of 1/3? The sides of the image also have the same scale factor, is what I'm trying to say. Got it? Okay. It's very, to me, this right here, if you were to go look at the book, that's why I'm telling it to you, because I looked at it and went, wow, that's really abstract. I want to be able to explain that to them. Okay. We got to go quickly now. Find the measure of the dilation image CD, C prime, D prime, using the given scale factor. Okay, so for each one of these, this is what I like to do. So originally, when we wrote this, we wrote C prime, D prime equals the absolute value of the scale factor times the original image, correct? So write that out and then go back and look at what information they gave you. They told us that CD is 15. This may seem obvious, but when it's the other way around, it's not so obvious. That's why I'm writing this out. So if CD is 15 and my scale factor is 3, what is C prime, D prime? 45. Got it? All right, let's do the next one. Find the measure of the preimage CD using the given scale factor for C prime, D prime. So what would I say again? C prime, D prime is equal to the absolute value of my scale factor times the original image. So this time I know that C prime, D prime is 7. I know that my scale factor is -2/3. I need to find CD. First of all, I wonder why they think they needed the whole absolute value. No. 2/3 is already going to reduce it, right? When you apply a fraction, you're going to make that object smaller. So if I'm going to make the object smaller, why would I need a negative sign? What do you think that negative sign is going to do? The direction. Good job. It's going to affect the direction. So the object's going to get smaller in terms of the center point, but instead of going in the same direction, it's going to go the opposite direction. Okay? So that's why I can say that 7 equals the absolute value. So it's going to make it smaller by 2/3. You should, whenever you see fractions, you should be thinking clear the denominator. So to clear the denominator, what would I multiply both sides by? 3, which would give me 2 CDs equals 21. So 1 CD equals 10.5. And I'm going fast because I heard that 7-minute bell. Ready? Okay. Draw the dilation image of trapezoid PQRS with center C and R equals to -3. So this time I'm going to do like that example in the very beginning. But instead of, if you notice, they had the image that was going away from C like this. And then the next one would be, if it was 3, would be 3 times that line out here. Correct? And this one would be 3 times that line in this direction. But since we're going in the negative direction, just like Devin said, this line is going to be times 3 in the opposite direction. So let's just eyeball it. 1, 2, 3. I'm going to say that's 3. I'm going to do R the same way. So R prime is going to be in this direction about 3 times the size. And P is going to be in this direction now 3 times, which is probably, there's 1, 2, I don't know, would you say 3 about there? And S is going to be, there's 1 length, I'm going to multiply that by 3 and go out this way. So what's this point? R what? R prime, and this one is S prime, and this one is P prime, and this one is Q prime. And if I were to connect all of these, I need a solid line. I would have an image, which is a trapezoid, that's, that is how much larger than this one? 3 times as large. Make sense? Okay. Coordinate geometry. If this is my preimage and I'm applying a scale factor of 1/4, how much smaller are each one of these going to be? They're going to be reduced by 1/4. How much is 8 reduced by 1/4? 2. How much is -8 reduced by 1/4? -2. So all of these will be cut by 1/4. So my original image is -8, 4, -4, 8, 8, 4, and -4, -8. My new image is going to be reduced by how much? By 1/4. My new image would be -2, 1. These are the easiest, I think. -1, 2, 2, 1, and -1, -2. Do those look the same? What do you guys think? It's not too hard. It's just the last step. Ready? Determine the scale factor used for this dilation. Here's the key, just real quick. All you really need to know is that you need to put the pre-image goes in the denominator, because that's what we're comparing to, right? Whenever you compare something, you're comparing to what it started with, right? So when I have a pie and I want to divide a pie by, I don't know, 3, and it normally has 12 slices, I wouldn't put the 3 in the denominator, right? You would talk about all of the pieces, right, that we were originally talking about would go in the denominator. So the original image, the preimage, needs to go in the denominator. So how long is the side of this preimage? 1, 2, 3, 4, 5, 6. And how long is the new image? No? 2. So what's the scale factor? A third. And no matter which side I measured, because these are similar triangles, right? No matter which side I did, I would always get 1/3. Make sense? What do you think this one's going to be? 1/1. I go up 1/4. Isn't that 1 squared plus 4 squared? Which equals √5. So it's going to end up being √5/√5. I know I'm going really, really fast, guys, but I don't think I really need to explain that this is the same size as that one. All you have to do is use distance formula to measure each side. And the last one I want to talk about. I have a picture that's got 20 by 25 centimeters with a frame that's 400 by 500. I've got to change it, this one, to centimeters. Okay? There are 10 millimeters in a centimeter. So what do you think I'm going to do? Divide by 10. When I divide by 10, don't I just, thank you, drop zeros? Exactly. So wouldn't that change this to centimeters? It would be 40 centimeters and 50 centimeters. Compare the sides. What's the scale factor? How much bigger is this than this? Times 2. Okay, that's it.